Hi, and welcome to Physical Science for April 27th. We are now in Unit 8, Lesson 1, and we're looking at electric charge and static electricity. And so today we're going to go through the digital lesson, and then I'm going to show you a review video on the website Vocabulary, and then I'll show you SLPass and how you can review this SOL, and then we'll look at tomorrow's lesson that I'll have for you, which will be a printed worksheet. Today I'm going to show you the digital lesson, but I just wanted to let you see that there are 6 lessons in this unit, so we'll be looking at it over the next couple of weeks. As you see, lesson 1 is electric charge and static electricity. And so I'm going to show you the digital lesson view for today. And hopefully this will work because my internet has been running quite slowly today.
Watch a bouquet of flowers disappear. You wonder, how did the magician? Magic shows are fun. As you watch a bouquet of flowers disappear, you wonder, how did the magician do that? Magic tricks are often illusions, meaning what you think you see is not what really happened. However, some magic tricks are based on science. Click each highlighted area to see how this magic trick is a real electrical phenomenon. When done, click the next arrow to learn more about electric charge and static electricity. First, the magician runs a plastic comb through the assistant's hair about 10 times. The comb then becomes charged with static electricity. Next, the magician has the assistant pour a thin stream of water out of the pitcher. If you try this at home, you can use a sink. Make sure you have a steady, thin stream of water coming out of the faucet. Now the magician moves the comb slowly toward the water. As the comb gets closer, the water bends toward the comb. It seems like magic, but it's actually science. The negative charge of the static electricity on the comb attracts the water, making the stream of water bend. Welcome to the lesson, Electric Charge and Static Electricity, where you'll learn about electric charge and how static electricity is transferred between objects. The vocabulary words for this lesson are electric charge, static electricity, electrical conductor, electrical insulator, and semiconductor. Did you know that lightning is a discharge of static electricity? It's true. Lightning is similar to getting shocked when you touch a doorknob after shuffling your feet across a carpet, except lightning is a lot more powerful. You'll learn more about static electricity in this lesson. Sometimes objects have an electric charge, causing interactions between particles. But how do objects get those charges? We can find the answer in atoms. Click the highlighted areas of the atom to learn more about electric charges. A proton is a positively charged particle in the nucleus of an atom. The number of protons in an atom does not change. A neutron is located in the nucleus of an atom. A neutron has no electrical charge. Electrons orbit the nucleus of an atom and are negatively charged. An atom is neutral if it has the same number of protons and electrons. Atoms can gain or lose electrons. If a neutral atom gains an electron, the atom becomes negatively charged. The charge is -1. If a neutral atom loses an electron, the atom becomes positively charged. The charge is +1. Electric charge is a property of matter that causes interactions between particles that make up matter. Click the images to learn more about electric charge interactions. As you've learned, objects become charged when they gain or lose electrons. In this illustration, both of the balls are positively charged. Do you see how they move away from each other? Two positive charges repel each other. The greater the charge, the greater the force of repulsion. What is happening to the two negative charges in this illustration? The two negative charges repel each other. Much like the two positive charges, the greater the charge, the greater the force of repulsion. While like charges repel each other, opposite charges attract each other. You can see that the negative and positive charges move closer together. The attraction or repulsion due to electric charge weakens with distance. Objects that are farther apart do not have as much interaction as objects that are close together. Here are two sets of charged objects. Label each object with the proper charge based on how they interact. Drag the charge to the correct image.
And so if we were at school right now, you'd be able to come up to the board and do this.
Great work! Like charges repel and opposite charges attract. There are 3 different ways electric charges are transferred. Click the images to learn more. It's shocking. Did you ever slide down a slide or jump on a trampoline and notice your hair stood up? This happens because electric charge is transferred by friction. When two objects are rubbed together, electrons jump from one object to the other. One object becomes positively charged, the other negatively charged. The transfer of charge causes your hair to stand on end. Electric charge can be transferred by direct contact. This Van de Graaff generator forms an electrical charge. When the student touches the generator ball, the charge is transferred from the ball to the student. Induction occurs when a charged object comes near an uncharged object, causing a separation of charges in the neutral object. If a positively charged bar approaches a neutral electroscope, electrons in the electroscope are attracted toward the bar. When electrons move toward the bar, the leaves both become positively charged. Because like charges repel, the two metal leaves will move apart. It's shocking. Electric discharge occurs when the electrons from a negatively charged object are transferred quickly to a positively charged object. This causes a shock, like you would get if you were to touch a doorknob after shuffling your feet across the carpet. These shocks are not harmful, but they can sometimes be strong enough to be painful. When charge is transferred from one object to another, the total number of positive charges and negative charges remain the same. Charges are only moved between objects. This is called the law of conservation of electric charge. Lightning is caused by electric charges separating within clouds. Click the dots on the line to learn more about the formation of lightning. The large cumulonimbus clouds that develop in thunderstorms have hailstones and ice crystals in them. As ice crystals blow around and hit each other, electrons get knocked off of them. Strong updrafts carry the positively charged hail to the top of the cloud. Free electrons move toward the bottom of the cloud. Many objects on the ground have a positive charge. Just as opposite charges are separated within the cloud, they are also separated between the cloud and the ground. But the cloud and the ground are far away from each other. As the charges continue to separate in the cloud, the charge gets stronger and stronger. When the charge in the cloud becomes strong enough, it is attracted to the tallest positive charge on the ground. This powerful discharge causes a lightning bolt. Lightning can also occur within the cloud as the negative charges at the bottom of the cloud are attracted to the positive charges at the top of the cloud. These images show different ways that electric charge can be transferred. Which one shows induction? Click the correct answer. You can roll over the images to find out what they are.
So I'm just going to roll over each object.
Not quite. This shows transfer of charge by friction. That's correct. The leaves in an electroscope show separation of charge by induction. Induction occurs when a charged object approaches a neutral object, causing a separation of charge. In induction, charges on a neutral object are rearranged so that parts of the object become positively charged and other parts become negatively charged. An electrical conductor is a material that transfers energy easily. Many metals are good conductors of electricity. Click the images to learn more about good conductors. Copper is one of the most common electrical conductors. Copper transfers electrical energy easily, can be drawn into thin wires, and is fairly inexpensive in comparison to some other metals. Gold, as seen on this memory card, is another good conductor. Gold transfers charge easily and is reliable. Gold is used in electronics in small amounts. Silver transfers charge easily. However, silver is expensive and tarnishes easily, so it is not used often. Aluminum is a much more affordable conductor than silver and gold. Aluminum is often used in high power lines because it is cheaper, lighter, and stronger than other conductors. However, aluminum does not transfer charge as well as copper does. An electrical insulator is a material that reduces or prevents the transfer of electrical charge. Click the images to learn more about different types of insulators. Wires are covered with an insulator to protect people from an electrical charge and potential fire. The insulator prevents the electrical charge from traveling from the wire to its surroundings. PVC, rubber, glass, and Teflon are all common insulators. Glass is used as an insulator for telephone and high-powered electrical wires. Ceramic is a highly effective electrical insulator. PVC, a special type of plastic, and other plastics are used to insulate electrical circuits. Many electrical wires in consumer products use 2 or more of these insulators, or a composite of these materials. A semiconductor is an element or a compound that conducts electric current better than an insulator does, but not as well as a conductor does. Semiconductors have a huge effect on our lives and have transformed modern technology. Examples of semiconductors are the elements silicon and germanium. Click the images to learn about semiconductors you might come across every day. Microprocessor computer chips are silicon semiconductors that are crucial to computers. Televisions and LCD displays use semiconductor technology. Cell phones use semiconductors in their electronic components. Radios use semiconductors to receive radio signals and transmit sound through the speakers. Semiconductors are very sensitive to small electrical currents. People working with semiconductors in development wear anti-static suits to avoid damaging them. Let's see what you remember about conductors and insulators. Sort the images into the correct boxes. You can roll over the images to find out what they are.
So I'm just going to take each one and see where it fits.
Great job! Many metals are conductors and can transfer a charge easily. Insulators protect against electrical charge. Look at this atom. What overall charge does this atom have? Click the correct answer. That's not correct. An atom with a neutral charge has the same number of protons and electrons. You can try. Not quite. An atom with a negative charge has more electrons than protons. Try again. That's correct. This atom has one less electron than it has protons. Therefore, it has a positive charge. When an
Oops, I'm sorry about that. I can come back to it.
This image
I'll come back to this and just go to
Look
the
at this atom.
answer.
What overall charge does... That's correct. This atom has one less electron than it has protons. Therefore, it has a positive charge. When an atom has less electrons than protons, the atom has a positive charge. When an atom has more electrons than protons, the atom has a negative charge.
All right, I'm going to skip to this over the next one because it would be typing an answer, and so I'll just go to the review.
This You've learned a lot about electric charge. Let's review the main ideas from the lesson. Matter is made up of atoms that contain positively charged protons, negatively charged electrons, and neutrons which have no electric charge. When atoms gain or lose electrons, they become electrically charged. An atom that has more protons than electrons is positively charged. An atom that has more electrons than protons is negatively charged. Like charges repel, and opposite charges attract. The electrical force between two objects depends on the object's charge and the distance between the objects. An electric charge can be transferred in three ways: by friction, by direct contact, and by induction. Conductors transfer electric charge easily. Copper, gold, and silver are examples of electric conductors. Insulators stop an electric charge from flowing. Plastic, glass, PVC, and rubber are examples of insulators. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.
Okay, I'm going to show you now a video clip from the website Flowcabulary, and I'm going to play this video first, and then we'll do the review together.
Yeah. Static. Electricity. Yeah. Yo. You ever shuffle around on a rug and then shock the next person you touch? It's not magic, you just have static electricity, so don't be mad at it. All matter's made from atoms too small to see, but we could peek inside them, just follow me. An atom has electrons, they're super small. They're one of its three main particles. Protons are positive, neutrons are neutral, and electrons are negative. That is crucial. Protons and neutrons chill in the center of the atom, while electrons zoom around on adventures. When electrons and protons have the same number, the atoms are neutral, no charge, no wonder. But friction from rubbing, it can cause electrons to leave. Now the atoms are charged. Fewer electrons means a positive charge for your hair. Let's see where those electrons are. The electrons were gained by this balloon, so it's negatively charged. Ha ha ha, look at you.
Static electricity. Some new electrons get to me.
Those same electrons left from me. Now a neutral charge is what they want.
Hey, static electricity. Some new electrons get to me.
Those same electrons left from me. Now a neutral charge is what they want.
Hey yo, did you know that atoms want it so? The number of protons and electrons is equal. So when extra electrons see empty seats on a nearby atom, they're like, when they leave, it restores balance. Anytime electrons build up, it can happen. And this build up of electricity is what leads to static discharge. See, static means lacking in movement. It's called static electricity because the charge charges stay in one place for a while before jumping to another object, rather than flowing to form a current. Know what I mean? Yo, some materials called conductors let electrons move through them easily, but other materials that we call insulators, they resist electrons moving through them. Okay, so if extra electrons say see you later and jump over to an insulator, the negative charge will stay in that place. But with the conductor, that's not the case. Then the charge is distributed throughout the entire object without a doubt. Either way, static discharge can happen, right? It's what shocks your skin and makes lightning bright.
Static electricity, some new electrons get to me.
Those same electrons left from me. Now a neutral charge is what they want.
Hey, static electricity, some new electrons get to me.
Those same electrons left from me. Now a neutral charge is what they want.
Hey.
Here we're going to look at the quick review. And what I'll do is I'll read each question and then you can answer out loud or to yourself. And then I'll show you the answer. What is all matter made from? Atoms. Which particles in an atom are positive? Protons. Which particles in an atom are neutral? Neutrons. What kind of charge do electrons have? Negative. When is an atom neutral? When it has the same number of protons and electrons. An atom with fewer electrons than protons has a blank charge. Positive. What does static mean? Lacking in movement. What kind of materials resist electrons moving through them? Insulators. What shocks your skin and makes lightning flash? A static discharge. So when this pre-recorded Zoom is complete, I would like you to go on SOL Pass, and you will see in your lesson plan that I emailed your parents for today. I'm going to ask you to go on SOL Pass and look at PS11, which is electromagnetism. So I'll show that to you right now. I know you've been on this website plenty of times, but just to make sure, in case you forgot, you'll type in solpass.org, and the sign-in information is on the list of online sites that are in the packet that I did resend to you. Hopefully you're going to get that packet today or tomorrow, but if you don't have it, then please have your parents email me. So what you need to do first when you get to this website is to log in, and our sign-in is Rivermont Roanoke, and our password is Bulldogs. And then I'll ask you to click on middle school. Go to physical science, and then you're going to see SOL number 11 for electromagnetism. And so on this site right here for today, you can pick a number of different things. You can go, you can review the study guide if you want to. There are different questions, the release questions, and then we have a matchup game, a millionaire game, a brain pop, a couple of different brain pops. Definitely go on this website afterwards, even if it's just maybe 10 minutes, 15 minutes, and just review. Again, if you have any questions, you can have your parents email me. So again, hopefully you will receive your packet 3 today. If not tomorrow, you're going to be assigned for tomorrow's lesson to answer the questions on this worksheet titled Static Electricity. And again, this is in the learning plan if you look at the daily activities. So try your best on this. And then the next time we come back for the next lesson, I'll show you the answers for this worksheet. So try your best. All right, so again, here's the information. When you're finished watching this, please go on SOL Pass. And tomorrow's lesson, again, will be the worksheet I just showed you. And like I said, we'll go over the questions when we meet next for the next lesson. So try your best. I hope you all have a great day. And again, email me any questions you might have.